In this lab, we were determining charges on repelling balloons. Our goal was to determine the charges on the pair of small balloons and understand why balloons behave the way they do. We collected data in 3 trials to ensure consistency, and we used Coulomb's law to calculate the charge of each of the balloons, which we determined to be 1.727 times 10 to the negative 6 coulombs on average.
3 models were used to determine the charges on the balloons. The first was the system schema, which represents how the charges are interacting with each other through an electrical force. Next was Coulomb's law. K is the electric constant, Q represents the charges, and R represents the distance between the charges. Finally, the free body diagram. The model represents a free body diagram of one of the balloons being suspended by a separate string that is taped at a single point on a whiteboard.
We designed an experiment to showcase electrical repulsion charges using balloons. We rubbed the balloons together on the carpet so that it could accumulate charge. Then we taped the balloons to a level surface, such as a whiteboard, where they were attached to strings of equal length. When we let go of the balloons, we observed how the electrical force acted between the 2 balloons to see if they would repel or attract each other. We repeated the procedure 3 times to get accurate data and to avoid sources of error.
The assumptions made during this experiment were important to not only reach mathematical conclusions, but could also be a source of error. For starters, it was assumed that when the balloons repel each other with the same charge, the acceleration was 0. Additionally, both balloons were regarded as having negative charge. Next, it was assumed for the sake of simplicity that the string and the tape holding the balloons were massless. Another assumption was that the balloons had identical mass. Finally, it was assumed that the whiteboard holding the string and balloons was being held completely horizontal while our trials were being run.
We determined these calculations by creating a free body diagram of our setup. Because of our assumptions stated earlier, such as how the balloons are approximately the same mass and the strings are massless, we determined that the y component of the tension force would be equal to the gravitational force since the balloons are not accelerating in the y direction. Then we determined that the x component of the tension force would be equal to the electric force that acts on the balloon when the acceleration of the balloon in the x direction is 0. We measured the angle between 2 balloons using a protractor and tracker software and divided that measurement in half. We also measured the distance between the balloons when their acceleration was 0 using tracker software as well. We only did calculations for the balloon on the left in each trial since we assumed that the balloons would have the same or similar tension and gravitational forces. So why did this happen to the balloons? Because of the concept like repels like, the balloons both possess the same charge, meaning that they would repel each other. Electrons were transferred to both the balloons, so they both became negatively charged. And repulsive forces acted on the balloons, more specifically by Coulomb's force.
A few things could have affected the accuracy of our experiment. The first, having so many assumptions to make math simpler ultimately leads to sources of error when they all add up in the end. Additional sources of error are that we may have not completely neutralized the balloons between trials, so they may not have been exactly the same charge at the beginning of each experiment. Next, we may not have held the meter stick completely parallel to the ground and could have put more force on one side than the other. This could have changed the force of gravity on the balloons. We also ignored the mass of the strings in our calculations, which could have interfered with the force of gravity during the calculations. And finally, our balloons were not equal to each other in mass, which could lead to inaccuracies in our actual calculations.